viewers, my name is SP Tobela. I'm a lecturer at Ehlanzeni TVET College based at Mashishing campus under the program Engineering and Related Design. So today I'll be offering you Engineering System NQF Level 2. So we'll be looking at the topic that says Selecting Engineering Systems Applications. So we have three types of engineering systems applications, of which it's a gear drive, a belt drive, and a chain drive. But today, I want us to check the gear drives. What do you mean when we say it's a gear drive? We say it's a gear drive is when it's a series of gears of which are used to transmit a motion and power from one shaft to another. It's a series of gears of which are used to transmit a motion and power from one shaft to another. Once again, let's just check at the types of gear drives that we have. We have a simple gear train. We also have a compound gear train. Then let us look at the simple gear train. Then by a simple gear train, we mean is when two gears are in mesh. When two gears are in mesh, you say it's a simple gear train. So then if you can look from that diagram or from our picture, if you can look from, okay, it's when two gears are in mesh. And if you can look from our picture, it shows gear A and gear B, of which gear A, it's a driver gear, gear B, it's a driven gear. And you can also notice that gear A and gear E, they move in different direction, means that they oppose each other. So for a simple gear drive or train, simple gear train, we say it's gear A, and we also have gear B. And we say that gear A is the driver gear, and gear B, it's our driven gear. Then we will explain this later. So now I want us to also check what do you mean by compound gear drives. Compound gear drive, we say, is when more than two gears are used, e.g. a motor vehicle gearbox. When more than two gears are used, we say it's a compound gear drive. Then, as we can check from our picture, we have three gears that are in mesh, of which the first one is gear A, the second one is gear B, and the third one is gear D. This is our compound. We say it's our compound. It's our compound. It's our compound gear drive. It's our compound gear drives, of which we have three gears. Same applies, say it's gear A, it's gear B, I hope it's clear, it's gear C. If you can check, these three gears, they are in mesh. So then I want us to focus, what do you mean if you say it's a driven gear? Remember from our simple gear drive, I said our gear A, it's a driver gear, and I said our gear B, it's our driven gear. So we say a driver gear is the gear that turns first and provide input. It turns first and provide input. We say a driver gear is the gear that turns first and provide input. It turns first and provide input. And we say that a driver gear, it's always connected to the motor. And then now we look at what do you mean by driven gear. A driven gear, we say, is the gear that is being turned by a driver gear and that provides the output. it provides the output. That is why we say that our gear A, it's a driver gear. Our gear B, it's a driven gear, if you focus on our simple gear drives. Then now, we also have an eagle gear. What do you mean by an eagle gear? We say a gear is a gear that maintains the driver and the driven gear. It's a gear that maintains the driver and driven gear. So this one, you only find it on compound gears or on compound gear drive. Remember, we already said that this one, of which it's our driver gear, we already said that A is our driver gear from our simple gear drive, and then the one that provides output, we already said it's our driven gear. So then this one, of which it's gear B, of which is our idler gear, we say it maintains the driver gear and the driven gear. So by saying so, we mean that it makes sure that the driver gear and the driven gear, it turns at the same direction. So then now, I want us to check the advantages of a gear drive compared to other drives. Then let us first focus on the advantages. Advantages, number one, you say they are compact in size, meaning that they come in various sizes. Number two, we say the velocity ratio remains constant. Remember, we say the gear drives, they are always meshed, or the gear drive. So if the gear drives are meshed, means that the velocity ratio will always be maintained. And then number three, we say the gear drives can transmit more power compared to other drives. And the last one, we say the gear drives are very reliable. So if you can check, these are the 4 advantages that you have. Let us check the disadvantages of a gear drive. The disadvantages, we say, number one, it requires a lubrication plan. Then if you say it requires a lubrication plan, I've said earlier on that all engineering parts, they require to be lubricated. And if you check the gear drives, they need to be lubricated since they are not like hydraulic drives. Remember, on lesson 2, we say that hydraulic drives, they are self-lubricated. But then if you concentrate on these gear drives, they need a lubrication plan. And then number 2, we say they're costly to manufacture. They are very costly. Or we need to have money to be able to manufacture these drives. And then number 3, we say they require skilled personnel to manufacture, and it's not easy. So we need someone who is competent enough to be able to maintain the gears. And then lastly, we say it requires exact alignment of shaft. So if you can check, if you say it requires the exact alignment, if you can check, the gears, they always need to be aligned to each other. They always need to be aligned to each other. That is why we say they are always meshed. So now, since we have discussed the advantages and the disadvantages of a gear drive, I want us to focus on the formula that we use to calculate the speed at which a gear drive rotates. The formula that we'll use at which a gear drive rotates. So the formula that we'll use, it says NA times TA is equals to NB times TB. So let's take this as our A. Let's use this diagram, of which let's say it's gear A. Let's use this diagram. This diagram, say we have gear A and gear B. And then if you have gear A and gear B that are enmeshed, the formula says that your NA times your TA is the same as your NB multiplied by your TB. And then it says your NA, if you say NA, we are referring to the number of revolutions of gear A. N stands for the number of revolutions of a gear. But in this case, you say it's NA because it's gear A. And then if you say T, TA still, we say it's the number of teeth of gear A, the number of teeth on gear A. So the same applies with NP and TP. And NP still stands for the number of revolutions of gear B, and TP still stands for the number of teeth on gear B. So now, since you can see that this one only applies if we have two gears that are in mesh. So you say if we have more than two gears used, then the formula is as follows. So it's like in this case, let me draw. In this case, we have more than two gears that are in mesh, of which it's A, gear B, and gear C. So we say it's NA, TA is equals to NB, TB, and is the same as NC, TC, of which still the N stands for the number of revolutions and the TC stands for the number of teeth. So then we also calculate the formula. We also have a formula to calculate the velocity ratio, where we say the velocity ratio, of which is our VR, velocity ratio. Let me erase here. Velocity ratio, it can be given by the number of revolutions of gear A, of which number of revolutions of gear A, all over the number of revolutions of gear B. Number of revolutions of gear B. And you can say the velocity ratio, can still use the formula that says the velocity ratio is given by the number of teeth on gear B, of which it's TC, TP, of which is TP, all over TA. So this is the number of teeth of a driven gear all over the number of teeth of a driver gear. So then I want us to look at our examples. Then we're going to look at the example 1, of which is a simple gear train. So we're given as statement says, two gears A and B are in match. Gear A, the driver has 10 teeth and rotates at 1,050 rams per minute. And it says, calculate at what speed will gear B rotate if it has 15 teeth. So then, for us to be able to calculate, we must first draw the gears. To make things easier, we must first draw the gears, of which the gear A, we are given 10 teeth, of which it's TA, 10 teeth, and they say that they are in mesh with gear B. They are in mesh with gear B. And gear B, they say they are given 15 teeth, which means that the number of teeth in gear B, they are more than the number of teeth in gear A. The number of teeth in gear B, they are more than the number of teeth in gear A. And the statement also says that gear A rotates at 150 rams per minute. Remember, we say that our speed determined our speed by symbol N, of which it's NA is equal to 150 rams per minute. And the question says, calculate the speed at which gear B will rotate. So for us to calculate the speed, we say NA TA, since they are in mesh with gear B, of which it will be, and B, TB. And therefore, we have NA as 1050. We have NA as 150 times, we have our TA as 10 teeth. So we'll say 150 times 10. And therefore, we'll say equals to, we have our TB as 15 teeth. We have our TB as 15 teeth. Therefore, we have our unknown as NB. Then you say 150 times 10. If you say 150 times 10, you'll get 1,500. And then we say NB, of which is our rotational speed for gear B, times 15, you'll get 15 NB. Therefore, you divide both sides by 15. Since you want to make NB the sum of the formula, you divide by 15 both sides. Therefore, if you calculate your NB, you say 150 divided by 15, of which you'll get 100 revs per minute. 100 revs per minute. So this is how we calculate the simple geared train. Let's just look at our example 2. Example 2, we are given example 2. Given example 2, whereby you are supposed to calculate the compound gear drive. We say it's compound gear drive. So now let us look at the statement. The statement says, in the figure below, the driver gear A is attached to the shaft of the electrical motor, which has 20 teeth, and meshed with the eagle gear B with 80 teeth on a counter shaft. The driver gear C has 42 teeth on the counter shaft meshed with gear wheel D, which has 63 teeth, rotating at 2 rems per second. So now, our data here, remember there are 4 gears that are in mesh. So we'll say our data here, we have the driver gear, and we also have the driven, gear. So from our statement, they say that gear A is attached to the shaft. We say that if a gear that is attached to the shaft, we say it's a driver gear. So, and they said N gear A, of which you can also see from the diagram that's what's being given, it's 20 teeth. And they say that even gear C, it's also a driver gear. So TC, it's also a driver gear with 42 teeth. But then they say that gear B, that is attached to gear A, is a driven gear, and gear B have 80 teeth. So you say TB is equal to 80 teeth, and we say the gear wheel D also have 63 teeth, of which TD, it's 63 teeth. And then they say that gear D rotates at 2 revs per second. So gear D, of which it's NT, rotates at 2 revs per second. And then now we have our given data. And then now we're going to look at our question. The first question says that calculate the speed of the gear attached to the motor. The speed of a gear attached to the motor. So we say of which it's NA. NA is the speed of the motor attached to the gear. But then since we are given ND, we will say NA all over ND, whereby NA is the speed for the driver, and ND is the speed for the driven gear. So then you say NA all over ND, it will be equals to TB times TD, whereby TB and TD are the number of teeth, N equals to TA times TC. Then now we substitute NA. NA is what we are looking for. ND we are given is 2. Then the product of the driven gear, of which TB is 80 times TD is 63, all over the TA given as 20 times the TC given as 42. Then now we calculate, say 80 times 63 all over 20 times 42, of which you'll get 6. And on the other hand, we have our NA all over 2. So if you're looking for NA, then you cross multiply. Remember, since we are having equal sign. So therefore, our NA, it will be 2 times 6. And 2 times 6, it will be 12 revs per second. So this is how you're supposed to calculate the speed of a gear. So note this, you must know how to calculate the speed of a compound gear drive. You must also know how to calculate the speed of a simple gear drive. So this will be the end of our lesson today, of which we are focusing on gear drives. Therefore, our next lesson will be focusing on belt drives, of which is also engineering system application. And we'll be more focusing on the types of the belt drives, the advantages and disadvantages of the belt drives, and doing the calculation. If you have any question or any comment, you can still contact us on our website, of which is ehlanzenicollege.co.za. You can also contact us on our social media platform. On Facebook, it's Ehlanzeni TVET College. On YouTube, it's Ehlanzeni TVET College. And at Twitter, it's Ehlanzeni TVET. Thank you.